this one was inspired by watching Cosmic Ninja's native displacement tutorial. I'll leave the link in the description because it's very good. We don't hear much about Lightwave's native Falloffs because, let's be honest, it's a bit dull. But they do have their uses, so here's a couple of further examples that might trigger some ideas for you. So this scene just has two nulls in it. This plane null is a shape primitive type, radius 5 meters, and this is the null we'll be referencing. It has an item shape set to 2 meters, so we've got a meter radius from the center point. Anyways, let's get the surface editor up and jump into the nodes. The only thing I've set up is this item info, which is pointing to this base null here. Here are the Falloffs we're going to be talking about. I'm only going to talk about the axis in Cubic because you'll get an idea for what the others do. And Cosmic Ninja did a great demo of using the cylindrical. But what I would say, as with anything else, there's always more than one way to skin an egg. So for instance, if you wanted to grow your own spherical Falloff, let's get a distance and a logic node. We'll take the world position because that's basically what they used to call spot. So we'll get the distance from the world position to our null, and we'll plug that into the logic, out the logic into the color. Double click on this. If A is less than B, we get a nice perfect circle. Also, if we take the scale and put that into B, not only does the spot follow us around, we can also scale. Okay, so that's the first one. Let's remove that and get back our Falloff. Let's reset everything here. So the axis Falloff, let's just set it up. So point position, that will be our world spot position, if you like. So any point on this plane here. So we'll plonk that into the point position. Base position, that will be our null. So we'll put that into the base position. Let's take that into the Falloff, see what that gives us. Not quite what we were expecting, but we haven't quite finished yet. So what we need to do is we need to take the forward vector, not the rotation, but the forward into the axis. There we go. Okay, let's just tidy this up a little bit. So the nice thing about this is we can move this gradient around, but because we're using the axis, we can also rotate to the direction we want to go. Now all this is happening in a range of 0 to 1. You notice I said range there, so let's get a scalar value. Now that's set to 1, so if we plug that into the range, nothing should change. But if you wanted to extend that to, let's say, 5 meters, so this would be 0 and 5 meters would be sort of out here somewhere. That leads us nicely into the power input. Let's get another scalar. Now if we double click on this Falloff axis, you'll notice it defaults to linear. So you've got a nice linear gradient. But if we change this to power, this controls the fall off of that gradient. So you can have it nice and sharp, or you could pump it up quite high, depending on which end you wanted it to gradiate. Is that a word? Don't know. To be honest, I wouldn't quite use it like this. I would probably set it to linear and put a gradient out of here into the color. But it's nice to have other options. Let's try a quick use case on this. So let's remove this scalar here out of the range, and I'm going to go for a turbulence node. I'm going to set that on the Y, and then I'm going to use the alpha as our range. I have a feeling my power number is a little bit on the powerful side, so let's take that down 0.2. Perhaps increase the contrast here a little bit in the scale. Let's take the power down a bit more, so you've got a bit more of a edge to this. So this could be quite nice for a burning effect, or perhaps we could use it as a weight, building instances on a landscape, trees on a landscape, something like that. Rotate around. Looks like waves on a beach. Let us clear all this lot out and start again. So we're going to talk about the cubic Falloff this time. I'm going to make a quick change to this null here. I'm going to change the item shape from ball to box. And again, let's reset. Let's just plug it up. So our world position into the point position, our position for the null into the center position, orientation. In this case, we do want the rotation. And we're also going to take the scale for the range. Fall off into the color. And here we are. So let's get a scalar node now. Plug that into the power, double click on the cubic node and set the fall off type to power. Nothing should happen because it's set to 1 still. So let's take that down. There we go. So we've got a nice sharp edge. So now our square follows our square. And when we rotate, the fall off is contained within this box. Now, because we're using scaling as the range, we can also scale this box. And it should follow exactly the outline of that square. So let's show this in a useful situation. But what I'm first going to do is I'm going to soften this edge here. So we have a nice slight fall off between the two edges here. And what I'm going to do is I'm just going to select all of this and copy it. I'm going to jump out of VPR mode and I'm going to load a pre-prepared sphere. And there it is, and I don't need the plane anymore, so let's just get rid of that. So this is going to be very similar to Cosmic Ninja's demo, but I'm going to use instances. So option C creates an instance of that. Now I've got DB&W's quick pick here, and I've got a shortcut straight to the instance generator. So in my case, I'll quickly go QU1 execute, and there it is. So here we go. There's my sphere, and I just want an array for now, 5 by 5, and I'll just take my box here and move it out of the way. So while it's still in the clipboard, let's go to the nodes and paste those in here. That's easy enough. The only thing I want now is the center point for each of these balls. So that is the base position in this case. So I'm going to take that into the point position and I'm going to use the fall off for the scale. So as we can see, nothing's happened. And the reason nothing has happened is because I've forgotten to put it to uniform. So there we go. Now it's on uniform. Now if I move my box around, it should scale accordingly. So if I now make it larger, they all disappear. So that's pretty cool. Let's take it a little bit further. Let's get a random vector. We'll take the ID index into that. And then we'll scatter these around. So let's just go something quite a lot. Let's go just -5. And we'll put that into the offset. Now, same reason as before, that nothing's happening there because under offset it needs to be set to uniform. So that's universally random there, which is not what we want. So let's go back into the nodes. So under vector scale, we'll get one of those. We'll take the output of there. We'll take the output of the random vector into there, that into there. Okay, so as you see, nothing's changed, but the inverse of the fall loss is the strength. So let's take the strength into the scale, and then we will see everything moves about within the radius of this box. So let's scale that up. So if we wanted, we could have almost like fake dynamics, I think. So we could go for 1. So we could have it popping off. Popping off. Make the box a bit bigger. Instant fizz. Or you could also experiment with the weight. Perhaps you wanted to go to nothing. Or perhaps you wanted the inverse of that. Perhaps the strength. So you just have the bits that jump around. That's quite nice as well. Talking of fizz, I just bought this extruded piece of type in here. I've shown this in the past, but it's quick enough to do. So let's turn this off from the render and we'll go to that one there so we can see what we're doing. Pop back into the instance generator. These we can make a little bit smaller. We'll need to go nodally for that. So let's put a remap in there. So input, result, We're currently set to 100%. Let's just go to 0.8 for the sake of processing power. Compress these up a little bit. Okay, that looks pretty good. Let's go to the node editor and we'll get a raycast geometry node. We want the base position of each of the instances, and we want the fizz to be our casting object, or our mask, if you like, and then we want the inside into the weight. And that should give us this. Now we may need to nudge the type because we get little artifacts. I'm not sure if that's just a mesh resolution thing, but anyway, that seems to work. That's good. Okay, let's hide that. So it says fizz, and then all I have to do now is take my null move it around. We should get an instant fizz. Yeah, works a treat. And obviously we can turn that around to our liking. I hope that was of use. Until the next time.